dilution is whenever you take a concentrated solution, so it's already in solution form, and you add water or add solvent and make it less concentrated. So like, for example, if I had a 6 molar HCl and went to a 3 molar HCl, by doing that, I am diluting the solution. Yeah, I'm making the amount of solvent per volume smaller. Excuse me, amount of solute per volume smaller. So, by definition, you are making the amount of solvent greater, therefore changing the concentration. All right? Now, this is the easiest formula to use for that. The problem is that a lot of people want to do a stoichiometry problem with this when they see a problem like this. But what happens is it's not stoichiometry, because I want you to notice that this is 350 milliliters of 6 molar HCl and right here, and you still have HCl here. Remember, stoichiometry problems, you were changing compounds, so you had to have an equation. All right? And so this is the same substance. That's a key. You know to do a dilution problem if you start with a certain molarity of one substance and you're finding out something about the molarity of the same substance. That is the key. All right? So here's what I'm going to do. It's pretty easy. I'm going to say, okay, M1 times V1 equals M2 times V2. My M1 is 6 molar HCl. I'm going to multiply that by 350 milliliters. That's going to equal, I know my molarity of what I want to go to. And I am looking for volume. That's what I don't know. Okay? So, if I do this math, then I'm going to say, oh, let me mention before I even do it. Notice that I didn't have to change molarity to grams or anything like that, or milliliters to liters. I can change milliliters to liters if I want to, but it doesn't matter because my units are going to cancel out and do all that kind of stuff. Pardon me?
Is it ever necessary?
No, it's not. All right? So, what I'm going to do is I'm going to say 6 times 350, and this gives me 2,100 moles per milliliter if I want to keep everything. And then I'm going to divide that by 2.5. This is moles and milliliter. This is just molarity. Molarity is going to cancel out and give me milliliters to equal V2. Does everybody understand what I did there mathematically? So I multiply this, divide it by 2.5. So when I do that, my answer comes out to be 840 milliliters equals V2. Now this is important. I want everybody to listen to me. Don't do anything else because this is important. That means that if I take this much 6 molar HCl and 350 milliliters of that, and I have that in a container, then to get my molarity to be 2.5, I have to have a total volume of 840 milliliters. Sorry about that, milliliters. Now, look at what my question says. This is where most people mess up. This is fine. Everybody says, oh, that's my answer. That's not your answer. Because the question was, how much water must be added to 350 milliliters? I've got 840. I already had 350. I have to subtract that 350 away from that. So 840 minus 350 means I have to add 490 milliliters of water. All right? That's where this problem is a little bit difficult. Okay? So, again, let me say that again. All right? So, the question was, how much water must be added to 350 milliliters? So, in other words, I've already got 350 milliliters of water in there to produce 2.5 molar HCl. I know that I have to have 840 milliliters of solution. That's how much I have to have total solution. I already have 350 of that. So I don't add 840, I add the difference between 840 and 350. So what I'm going to do, let me extend this a little bit. So I'm going to just say 840 milliliters minus 350 milliliters equals 490 milliliters. This is how much has to be added. This is how much I want to have to begin at the end. But that's how much water I have to add. Any questions there? Probably. All right. Now, so this one, here's a new example. All right. So in this case, what is the new molarity of an acid if 150 milliliters of water is added to 50 milliliters of 2.54 moles per liter of the same acid? Again, the formula is M1V1 equals M2V2. I'm looking for molarity. This molarity here, I don't know. This is how much water is added. Okay, that's not my total amount, that's how much is added. I'm starting with 50 milliliters of 2.54 molar. All right? I'm looking for this molarity. What am I going to put for volume? Does anybody know? What am I going to put for my volume there? 200. 200. I'm going to add it this time. Because look what happened. I've got 50. I'm adding 150 milliliters is added to 50 milliliters. Okay? So this is a reverse problem. So here, my total amount is going to be 200 milliliters. That's important on these problems. You have to read it and make sure you understand. And so now when I do this math problem, 2.54 times 50, divide that by 200, and I get 0.635 molar equals M2, which, by the way, that is the correct number of significant digits because 50 and 2.54 have 3 significant digits. The key is making sure you don't miss this problem, this part of it. That's your answer. That's correct. All right.